Hello everyone. In this video I'm going to show you another approach to finding the resultant of a bunch of vectors using a trick. Instead of just using a graphical approach, now we're going to do a little bit of trick. We're going to do some math and stuff like that. All right, so I'm going to show you the theory first. So let's say I have a vector going this way. Let's call it v1. Okay, and maybe I have another vector going this way. Let's say that's a v2. And then maybe I have another one going this way. That's v3. Okay. The combination of all those is going to be this vector here. This is going to be my resultant because I add them head to tail. Now, if I take each one of those vectors and I break it down into an x component, and I'm going to break it into a y component. Because technically, if you have a vector going this way, you're going right and up. Okay, so here is the y component. So everything in green is the y components, anything in blue is the x components. Now, if you take the red one and you break it and you create an x component out of it, right here, and you create a y component out of it. Okay, so this is kind of like ry, and this is rx. Okay. Now, so basically we're taking the vector and we split it into horizontal and vertical components. In the past, we took vectors and we added them to get the resultant. So we kind of like almost like reversing the process. Okay, we're going from a vector and we're coming up with two possible components that can give you this resultant. Now, these are not the only two that can give you R. You can go here and here. You can go here and here. You can do an infinite number of possibilities. But I'm going to use x and y. This way I can make a right triangle. And I think we know how to work with the right triangles. Now, if you look at all the blue ones, if you take this blue one, this blue one, this blue one, and you add them up, you're going to end up with Rx. So I can say v1x plus v2x plus v3x plus etc., right? It could be a bunch more, is equal to the x component of the resultant. I can do the same thing for the y. And that's the idea I'm going to use to find the resultant. So here is the approach. We're going to take every vector that's given to us. We're going to break it into x and y components. And once we do that, we're going to take all the x components. We're going to add them together. We're going to take all the y components. We're going to add them together. So if we add them together, if we add the x and the y components together, we should get rx and ry. And we make a triangle, and from that triangle we can find r, because we're going to end up with a right triangle, and we can even find this angle here. So that's the theory behind all this. So now let's put this to practice. I'm going to use an example here. And the example is, I'm going to do three vectors. v1 equals 17 meters per second at 10 degrees south of east. v2 is 10 meters per second at 40 degrees north of east, and v3 is 14 meters per second at 70 degrees north of east. Now, I'm not going to just add those three. I'm going to add v1, v2, and I'm going to subtract v3. Which means I'm going to need the opposite of v3. I'm going to need that. So this is pretty much what I'm looking for. v1 plus v2 minus v3. Now, how do you subtract a vector? You add its opposite. So this is kind of like adding the opposite. So I'm looking for this. I'm looking for this resultant here. The opposite of v3 is 14 meters per second, right, at 70 degrees. Now the north becomes south, and the east becomes west. You just do the opposite of the directions. Let's see how we do this. The way I do this, I do a chart. And I do the x component, the y component. And I put the vectors here. I put v1, put v2. And I don't put v3. I put the opposite of v3. And I break down these vectors. But before I do that, I do a quick sketch. v1 is 10 degrees south of east. So v1 is going to be kind of like that. Okay? v2 is north of east. v2 is going to be like that. okay? And negative V3 is going to be south of west. So negative V3 is going to be like this, kind of. So just to give me an idea. Now, then I'm going to start breaking them. Now, the way I break this, I can break them with the y component first and the x component first, but for our class, we're going to do the x first and the y second, because all our angles will be measured with respect to the x direction. So here. So basically, this is v1x, this is v1y. And we can do the same thing for all the other ones. So I always start with the horizontal piece first. This angle here is 10 degrees. This angle here is 40 degrees. And this is not drawn to scale by any means. This angle here is 70 degrees. Okay? Now, this V1 in magnitude, this leg here is 17. This here is 10. And this here is 14 meters per second. Now, well, if you know your trig, we can do SOHCAHTOA and figure out the x and the y components. So, but before I do that, because what I'm going to do next, the calculator will not give me that. I'm going to just look at my drawing. So for V1, the V1x is positive, so I'm going to put a plus here. The V1y is negative, put a minus. This for V2, they're both positive, because the calculator will not give you that. For V3, this is negative and this is negative, so they're both negative. Now I'm going to start putting numbers in. Now, you should have already watched the trig video. So V1x is the hypotenuse times the cosine of that. So make sure you are in degree mode. Let me check that. What am I? Yeah, mode. Yep, I'm in degrees. Okay, so I'm going to do 17 cosine of 10. So this one gives me 1379. Then I'm going to do, oh, I did 14. No, sorry, 17 cosine of 10. I did 14. So that's 1674. Then I do 17 sine, because the y is the opposite, sine of 10. I get 295. And then I do V2, which is 10 cosine of 40. That's 766. Then I do 10 sine of 40. I get 643. I'm rounding a little bit. And I do 14 cosine of 70 to get 4.79. And then I do 14 sine of 70 and I get 13.16. Okay, so I don't need these guys anymore. Now, the resultant, according to that theory that I showed you earlier, is just going to be the addition of these things here, right? So you just add 16.74 plus 7.66 and you subtract 4.79 and we should get 1961 positive. Then we do the other side, negative 2.95 plus 6.43 minus 13.16 and I get negative 9.68. Now I'm going to draw this, guys. These are the components. These two are the components of this. So I'm going to start with this. That's going right because that's positive. Okay, that's 19.61. This one is going down. So I'm going to come here and I'm going to go down because of the negative. But I'm not going to put the negative in there. Okay, the fact that it's going down means that it's negative. And here is my R. Okay, so I have to find this R in magnitude and I have to figure out what that angle is. Okay, so now I think for that I can do a lot of things. I can find the angle first and do a trig, do SOHCAHTOA to find R, or I can do Pythagorean theorem to find R first. Doesn't matter basically. All right, so I'm going to do Pythagorean theorem. So I'm going to take 9.68 and I'm going to square it. I'm going to take 19.61, I'm going to square it, and I'm going to take square root of that. So R is 21.87. Now the units here are meters per second, so this is going to be meters per second at Now I have to figure out this angle. Let's call it theta. Now, at this point, I can do anything I want because I know that this is 2187. So I'm going to do inverse tangent, opposite, adjacent. So I'm going to do second tangent, and I'm going to do 9.68 divided by 19.61. And my angle is 26.27. So let's just round it to the nearest degree, 26 degrees. Now, if that's east, this is south. I think it's south of east. South of east. And that's pretty much how you do that. Okay? All right, so we'll do some more examples in class. All right, guys, have a nice day. Bye-bye.